All right, continuing on. Here in number 8, we've got a system of equations. So two equations at the exact same time. And what we're going to do is we need to look for an ordered pair, x comma y, such that when we substitute those values into both of these equations at the same time, they're both made true. And let's do this one graphically, although you are welcome to use other methods of solving systems on this if you like. I'm going to hit up both substitution method and elimination method in the next two problems. So you'll get those as well. So let's start with the first one, which we will do in red. And what we want to do is we want to graph this equation, because if we can graph it, we will find all of the ordered pairs that make that true. So I'm just going to copy it down. All right, so we want to isolate y here. So let's subtract 18 from both sides. So negative 2y equals negative 18 minus 4x. We're going to divide both sides of this equation by negative 2. We're going to make sure to divide every part of this right-hand side by negative 2. We get y is equal to 9 plus 2x. We've got our y-intercept of 9. There it is right there. Let's go ahead and just label our axes. All right, I better put my money where my mouth is. If I'm telling people they always got to label their axes, I better label mine. And our slope is positive 2. So for a 1 unit increase in x, y should go up by 2. We'd be kind of a little bit off the graph up here, so let's go to the left. And I like to make a whole bunch of ordered pairs, just because it means that my graph is going to be all the more accurate when I draw it, which is a good thing. Gotta love making lines on the iPad. I got this cool trick, though, that a student taught me last year, is that if you kind of drag your stylus along the edge of the iPad, you can make a perfect line, and then you can just kind of tweak it until you get, an appropriately length and width line, and check it out. And this is gonna probably, all right, good. Let's try one more time. And all right, that's gonna have to be good enough for us. I'm gonna copy that so we have it later. All right, so that is our first line. That is the line y equals 9 plus 2x. And I always say to label those lines. Y equals 9 plus 2x. So every point on that line makes our first equation true in red. All right, now let's graph our second equation in green. So we've got 3y plus 9x equals 12. Let's go ahead and subtract 9x. 3y equals 12 minus 9x. All right, awesome. Divide both sides by 3, making sure to divide all parts of that right-hand side of the equation by 3. Y equals 4 minus 3x. We've got a y-intercept of 4 in this case, and a slope of negative 3. So that means for every 1 unit increase in x, we will have a 3 unit decrease in y. So let's make that happen. Boom, 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 boom. Let's go the other way as well. Boom. We can already see where our solution is going to be, but even so, for good measure, let's go ahead and graph that line. I'll check it out. Okay, close enough for me. Boom. All right, always want to put those arrows on our line. Ooh, that's not a very good line. Maybe I'll move it a little bit. I don't know. I'm going to get on people's cases about having accurately drawn lines. I better have accurately drawn lines, All right, good enough. Okay, and so let's go ahead and label that as well. That is the line y equals 4 minus 3x. And it is clear that they intersect at the point negative 1, comma 7. And so that means that since it is on the green line and the red line, that ordered pair should make both the green equation and the red equation true at the same time. Let's check just to make sure. All right, so if x were negative 1 and y were positive 7, so let's say negative 2 times 7 is negative 14, plus 18 is 4, and negative 4 times negative 1 is 4. Oh my god, this works. Awesome. If y is 7, so 3 times 7 is 21, plus 9 times negative 1, which is negative 9. So 21 plus negative 9 is 12. Amazing, amazing. It works. Fantastic. So again, always want to check those answers. All right, number 9. All right, so we've got a system of equations here, and I don't want to graph it. And I got to look, do we want to use the substitution method? You know what? Neither x nor y looks very easy to solve for in either of these equations. So let's use the elimination method. And the first thing I want to do is get all of my x's in a nice column, all my y's in a nice column, equaling some numbers in a nice column. So this topmost equation, I want to kind of rearrange it a little bit, and I want to do so by subtracting 2y from both sides of this equation, which would yield 5x minus 2y equals 4. Now we need to somehow kind of manufacture additive inverses on the coefficients of either x or y, and I'm thinking the easiest place to do is probably the x ones. So if we multiply both sides of this second equation by 2, we'll have a 10x, which when we add negative 10x to it, we'll get 0, so we'll have no more x's, and we'll have a nice equation with just y's in it. So here we go. Now here's the beauty of the iPad. I can just kind of toss this off to the side and kind of make a note to the reader that I'm taking this entire equation and I am multiplying both sides of it by 2. So we're going to get now 10x minus 4y equals 8. Okay, so here we go. And now what we're going to do is we're going to take this first equation here and we're going to add 8 to both sides of it. On the right-hand side, we're actually going to add the number 8. On the left-hand side, we're going to add something that is definitely also equal to 8. 10x minus 4y, right? It equals 8. We are assuming that both of these original statements are true at the same time, and then figuring out then what must be the solution. So when we add 8 to both sides of that original equation, we're going to end up with, well, negative 10x plus 10x is 0. Amazing. 5y plus negative 4y is just 1y. Amazing. Negative 11 plus 8 is negative 3. Phenom. Amazing. Check that out. We've already found, that was very lucky. We've already found the y coordinate of our solution to the system. And in order to then find the x coordinate, let's maybe just take our equation right here. You can take any of them. And let's substitute in y equals negative 3. Right here, boom. 2 times negative 3. I forgot, I should have written that 2 already in black. Trying to color coordinate it. And all right, so 5x equals 4. 2 times negative 3 is negative 6. So 5x equals negative 2 divided by 5. So our x coordinate of our solution is negative 2/5. Meaning our solution is the ordered pair. Always want to write it as an ordered pair. Negative 2/5, comma negative 3. Now what we really want to do is, oh god, I'm a little worried about this negative 2/5. Let's make sure that it actually works. So let's substitute in these values for their respective variables. So if x was negative 2/5 and y were negative 3, 5 times negative 2/5 is negative 2. 4 plus 2 times negative 3 is negative 6. 4 plus negative 6 is also negative 2. Whoa, it worked. Crazy. All right, negative 10 times negative 2/5 is going to be 4. And then 5 times negative 3 is negative 15. 4 plus negative 15 is negative 11. Oh my god. Amazing. Wow. All right, so even though we got this kind of nasty fraction solution, it definitely worked when we substituted it in. So definitely going to be our solution. So here's one where I use the elimination method. Hopefully we can use the substitution method in this one, just so we can hit them all. Oh, you know what? I'm thinking the substitution method is actually going to work. Not so bad. I'm looking at this first equation, and I see this 5m, and I know that to solve for m, or isolate m, I'm going to have to divide by 5, but with coefficients of 15 and 5 and 10, that's going to be okay. So let's go ahead and bring this equation elsewhere and solve for m in it. So, all right, let's just we're going to do our dirty work over here. 5m plus 15 equals 10k. Let's subtract 15, right? We're trying to isolate this m. 5m equals 10k minus 15. We'll divide both sides of this equation by 5, yielding, all right, so we've isolated m. M must be equal to 2k minus 3. Okay? Awesome. So we're assuming that both of these statements are true at the same time. And so if they are true at the same time, then n must be equal to 2k minus 3. So what we're going to do is we're going to substitute that 2k minus 3 right in here in the other equation. And let's see what we end up with. We end up with negative 7 times the quantity of, and just to color code it here, 2k minus 3. And then the rest of this equation remains the same, plus 14k equals negative 7. All right, let's solve away. We've got only k's here. Let's see what ends up happening. Negative 7 we're going to distribute here, so we get negative 14k plus 21 plus 14k, wait a second, equals negative 7. If we add these two guys together, kind of just collecting our variables here, well, they add to 0, negative 14k and positive 14k, and we end up with 21 equals negative 7. Like, huh? Well, that's an obviously false statement, which means that our assumption earlier that both of these could be true at the same time was obviously false. So that means there is no ordered pair that's ever going to make both of these statements true at the same time. This system of equations has no solutions. So once you get this obviously false statement, boom, no solutions to this system. All right, let's make some moves.